Assalamualaikum and hi. My name is Muhammad Adil Fadli bin Muhammad Elaya Yusof. My matric number is TA2007. So today I would like to share you my project 1, Hybrid Manufacturing of Directed Energy Depositions, DED in Process Impeller. Additive manufacturing AM process are reliable technique to build high complex metallic parts. Direct energy depositions (DED) is one of the most common technology to 3D print metal alloys. Despite a wide range of literature that has discussed the ability of DED in metal printing, weak binding, poor accuracy and raw surface still exist in final products. Thus, limitation in 3D printing of metal powder and wire indicate post-processing technique required to achieve high quality in both mechanical properties and surface quality. Therefore, hybrid manufacturing (HM), especially additive subtractive hybrid manufacturing (ASHM) of DED has been proposed to enhance product quality. ASHM is a capable process that combines two technologies with three axes or multiple axis machine. Different methods have been suggested to increase the accuracy of machine to find better quality and microstructure. In contrast, drawback in ASHM still exist such as limitation in existing reliable materials and poor accuracy in machine coordination to avoid collision in the multi-axis machines. It should be noted that there is no reviewer with focus on both DED and hybridizations of DED process. Now, I will share you about literature review. History of impeller component. The impeller, a vital component in many machines, it has developed dramatically through time. Its origin may be tracked back to the usage of water wheels for milling and irrigation by ancient civilization. Impellers gained increased significance in the 9th-10th century with the introduction of steam engines. The Industrial Revolution accelerated development in impeller design, materials and production process, allowing cast iron to give way to more durable materials and such as steel and alloys in the 20th century. Hybrid manufacturing advancements have further revolutionized impeller manufacture. Traditionally, manufacturing methods such as casting or forging are combined with cutting-edge additive manufacturing (AM) technologies such as a 3D printing in hybrid approach. Additive manufacturing allows for the production of complicated designs that were previously difficult to impossible to make traditionally, improving the impeller's efficiency and performance. Net is methodology. So, the materials that using in producing impeller is stainless steels, aluminum, titanium, and nickel-based superalloy. So, I will share you about the sequence of the process. Firstly is design. The impeller design is created using computer-aided design or CAD software. This design specifies the dimension, geometry, and other relevant details of the impeller. Second is additive manufacturing (DED). The initial phase involves the addition manufacturing process using DED. The impeller basic shape is built layer by layer by melting and depositing material from a metal wire or powder feed using a laser or electron beam. Third is subtractive manufacturing. After the additive phase, the impeller might undergo subtractive process such as machining or milling. This step refines the impeller's surface finish, dimension, and precise feather not achievable through additive method alone. And after the subtractive manufacturing operation, post-processing steps may be performed such as inspection or quality control, heat treatment, surface coating, or polishing to the further enhance and the properties and appearance of the impellers. Method of hybrid manufacturing process. First is wire feed additive manufacturing process. Wire feed technology are used to produce large and moderate complex structures such as a flank. This system is categorized into laser wire welding additive manufacturing (LWWAM) and wire arc additive manufacturing (WAAM). WWAM use laser as the main energy source and wire metal to build metal products. The metal wire can be cool or hard based on requirement. Second is laser direct metal deposition (LDMD). Another process of DED is laser direct metal depositions (LDMD), by which metal powder is used to fabricate a wide range of products. This process is suitable for the aerospace industry due to its high level of accuracy and precision. Metal powder is injected directly following laser irradiation to put 3D CAD file layer by layer. And third is hybrid CNC machines. Some manufacturers employ hybrid CNC machines that integrate both additive and subtractive process like milling and turning with additive process such as laser cladding or powder depositions. They enable the productions of impeller by 222. Next is result and discussion. First is optimizing parameters. The material used must possess suitable properties for additive manufacturing, such as a good printability and layer adhesions, as well as machinability for milling operations. Finding materials that have these characteristics and meet the desired performance requirements can be challenged, especially for the specialized or high-performance applications. Second is defect on the DED process. The possibility of porosity in the created pieces is one of possible problems with directed energy depositions (DED). Tiny voids or air pockets that may occur in a material during the deposition process are referred to as a porosity. Next is misalignment. Any misalignment, any misalignment or deviation can result in a mismatch between the printed and mill feathers, affecting the overall quality of the impeller. Misalignment in producing an impeller using DED refer to the discrepancy or deviation between the intended design and the actual build geometry during an additive manufacturing process. This misalignment can occur due to various factors such as a layer misalignment. Next is process achievement. Firstly is enhancement surface finish. Compared to conventional machining technique, hybrid 3D printing and 5-axis milling can produce surface with a better finish. A high-quality surface finish can be achieved during machining of the milling process. Impeller can be constructed via 3D printing, which minimize surface flaws and cut down on the quantity of materials that need to be machined. Second is enhanced lead time. In terms of producing complicated impeller more quickly, direct energy depositions (DED) is innovative. It sped up the design process by enabling us to rapidly improve and optimize their internal structures and shapes. As a result, testing and error correction only require less time. DED adds material with the high accuracy, reducing waste and post-processing labor requirements. Additionally, it is great at producing extremely complex forms all at once, streamlining and speeding up the production process. Third is strength and durability. When compared to the conventional machining technique, hybrid manufacturing can produce impellers that are stronger and more durable. The impeller can optimize properties by using 3D printing to produce custom blade design, impeller shape, and internal channels. The final milling procedure ensures dimensional precision and provide precise finishing. Next, I will share you about the project management. First is project initiation. Identify the necessity of utilizing hybrid 3D printings for impeller manufacturing. Assess feasibility and advantage of hybrid 3D printing approach. Analyze specific project requirement and objective. Obtain necessary approval for project initiations. Second is project planning. Develop a detailed project plan for manufacturing using hybrid 3D printing. Establish a workflow for combining conventional manufacturing method with 3D printing. Third is project executions. Prepare 3D printing equipment, set printing parameters, ensure availability of raw materials, utilize hybrid 3D printing process. Combine additive manufacturing with post-processing step. There is monitoring and control. Continuously monitor project progress. Ensure adherence to project plan and quality standard. Track that the printing process combine additive manufacturing with post-processing step. Lastly is project close. Mark completion of project wind down all the project activities related to manufacturing. Send the manufacturing impeller to the operating party, obtain final approval from quality control. Lastly, conclusion and recommendation. In conclusion, the article highlights the advantage of additive manufacturing of directed energy depositions (DED), basic of the process, material classification of DED process in 3D metal printing and streamlined production process. It suggests the further research and development should be conducted to maximize the benefit of additive manufacturing. This can be achieved through exploring design methodologies specific to additive manufacturing, conducting cost analysis to assess economic feasibility, and educating designers and engineers about the capabilities of the technology. The recommendation is to focus on design for additive manufacturing principles during the concept design phase to optimize design for additive manufacturing process. Conducting cost analysis and economic assessment will provide insight into the cost effectiveness of additive manufacturing for impeller production.